Suppose we have a Q-to-Q relationship, which is a quantitative explanatory and a quantitative response variable. We will use Desmo.com to construct the scatter plot and to find the equation of the best fit line. The first thing we'll do is to store the data in a table using Desmo. To do that, click on Add Item and then Table. Let's assume that we have the relationship between the number of minutes a student spent studying before the exam and their exam score. And so, for example, we asked the first student, how many minutes do you study for the exam? And we were given 100 minutes, and the score for this student on the exam is 81. And then we asked the second student, they spent 175 minutes, and the score is 75, and so on. Each of these order pair is an observation for one individual student. We cannot mix this up. The corresponding y is for a specific x. Once we're done entering the data into this table, we can ask for a scatter plot. Notice that we do not see any points on the graph yet. We can specify the minimum, the maximum for the x and the y axis, but there is a better option, and that is the zoom fit feature. Click on zoom fit and we'll see a scatter plot. Each dot represents an order pair. In this case, there seems to be no association between the number of times in minutes a student studying for the exam and the exam score. But if we must find the linear regression, we will type y sub 1, not y, tilde a plus bx sub 1. And the reason why we need to use x sub 1 and y sub 1 is because the label for the columns in the table is x sub 1 and y sub 1. And this is not an equal sign, it is tilde. Desmo.com gives us the equation of the best fit line, which is also known as the least square regression line. Y equals A is 99.287 plus B is negative 0.072 rounded to 3 decimal places x. Normally we would just simply write y equals 99.287 minus 0.072 x. Now we know that this scatter plot doesn't represent a linear equation, and that is also evidence in the correlation coefficient. The correlation coefficient is negative 0.2433, which is closer to 0, so this has a very weak linear relationship.